Okay, good evening, everyone. I'm here to talk about how to migrate from Thanos to Grafana Mimir, aka returning file to Prometheus. So you will learn that there are some issues with running Thanos, with your long-term data, and let's start it. Okay, who am I? I'm Pavel Štrobl, and I'm DevOps engineer at Prusa Research. I am mostly interested in observability and platform, and that's my daily job. And I'm as well the Cloud Native Prague organizer. We are organizing meetups in Prague, obviously, Cloud Native Prague. For my hobbies, I'm homebrewer. I can brew my own beer, and I play with hardware a lot. 3D printers, obviously, cars, embedded hardware. Okay, agenda. What are you going to talk about this evening? Quick reminder what Prometheus is. So we know what is Prometheus, what is Thanos, what is Grafana Mimir, their differences, and plus you can choose with the migration itself, and conclusion of the migration, because as you will learn, it's not that easy as it could be. Let's start with Prometheus. What is Prometheus? Prometheus is basically software for collecting metrics. If you have metrics of any kind, mostly in this time in like Kubernetes clusters, they are probably in Prometheus format. Prometheus scrapes metrics from /metrics. The endpoint collects them and stores them inside of its DSDB. Its second project in Cloud Native Computing Foundation. First one was Kubernetes, but it started 2012 at SoundCloud. And no, that's not the reason why the logo is orange. Most interesting is, like I said, Prometheus is scraping the metrics from the endpoints. It uses pull model, not push. You are not pushing data into Prometheus. You can, but mostly it's use the pull model. And version 2.0 is eternal, but fortunately, version 3.0 is coming. At last week at PromCon, 3.0 beta version was released, so you can download it and test it in production, obviously. Okay, I have questions for you. When Prometheus joined CNCF? 2015, 16, or 17? Who thinks it's 2015? Okay, we have like 3. Okay, 2016. Okay, 2017. Nobody. Okay, it's like on par, and it's 2016. So I said Kubernetes joined 2016 as well, and Prometheus was second project that joined CNCF. How Prometheus works? Prometheus basically does one thing and one thing only, and it does it well. But it cannot handle high availability, anything like that. No fancy things, only scraping metrics, storing them. That's it. It has its internal DSDB. Obviously, it's a metrics collection software, so it has DSDB. It's millisecond based, so if you have you want like nanosecond precision, you are out of luck. You need to use like Influx or something like that. Mostly in order. Out of order was addition into original setup and architecture, and pull versus push. Nowadays, you can use remote write to push into Prometheus. That's why out of order was implemented. And finally, remote write 2.0 is already on its way. Beta version is already implemented. Okay, another question. How many versions of Prometheus DSDB exists? Who thinks it's 1? Nobody. Who thinks it's 2? Okay, who thinks it's 3? It's 3, yeah. And not because Prometheus 3.0, but because in version 2.0 there was an issue and it has to be rewritten. What is Thanos? Thanos does what Prometheus don't. let's say you want to handle high availability. You can, because Prometheus doesn't have high availability support, and you will use Thanos for it. It's long-term storage. Prometheus cannot store data in long-term storage like S3 bucket, GCP bucket, S3 storage, or GCP buckets. High availability can run in multiple instances. Prometheus is like one binary, and it's run in like one binary. So you can scale technically Prometheus into 2 instances, but you are technically running 2 Prometheus instances that both of them scrapes the data from all the endpoints. And scalability. Thanks to non-monolithic architecture, you can scale every component of the Thanos that is available, and you can speed up, for example, queries processing. Thanos usual setup. This is not usual setup. This is our setup at Prusa Research. Okay, we are running Google Kubernetes engine, and we are running Thanos. Like this, yes. We are running Thanos. And Thanos uses something called Thanos sidecar that's running inside the Prometheus pod in Kubernetes, and it's running beside the Prometheus and sends the data into Google bucket in our case, or any other S3 compatible storage. We are running 2 instances, and thanks to Thanos sidecar, you can actually query the Prometheus itself. You don't have to query the S3 storage. That's slow, but you can query the Prometheus itself. That's much faster. So if you have like 7 days of data in Prometheus, Thanos knows that you have 7 days of data in Prometheus. It will query the Prometheus and not the S3 storage. This is architecture of the Thanos. We have Thanos sidecar here. We have Thanos ruler, Thanos query, Thanos targeted, Thanos compactor, etc., something like that. Thanos sidecar, as I said, can handle querying or sending data to object storage. Thanos ruler mostly for alert manager and evaluating the rules. Thanos query, processing the queries. Thanos store gateway, this is a most interesting component in this diagram, because that's the biggest bottleneck of whole Thanos architecture. And of course, Thanos compactor that gets rid of non-templated data. Features is pretty cheap to run. Prometheus is with Thanos runs like quarter of the price of the Sentry that we are running. Can be used nowadays for multiple tenants. Fortunately, it wasn't possible in the past, because it was like in version 0.34, something like that, was implemented. So it's pretty new feature. Community-driven development, which is very nice, of course. Scalability, and only a few downsides: speed and complexity with multiple layers of data, and that's the main reason why we are here. Grafana Mimir. What is Grafana Mimir? Grafana Mimir is basically fork of Cortex. If you know Cortex, you know Grafana Mimir. Also long-term storage, also high availability, also scalability, basically same as Thanos, right? No, we have right path. Thanos uses Thanos sidecar as asset to sending data into S3 bucket, S3 storage. Grafana Mimir uses remote write. Prometheus has to be configured to send data into Mimir, and Mimir sends data into S3 storage. Basically, it uses distributor that distributes the data all over the place, ingester that ingests the data, and then send to object storage. Read path is basically the same. Query frontend just splits the querier that's process the storage, the queries, and store gateway that's access the object storage. Okay, Thanos versus Mimir. Mimir is more expensive to run. You have much more components, And if you run it in high availability, you have even more components to run. What Mimir doesn't support is downsampling. It has same resolution of the data over time. So if you have 10 years of data, you have 10 years of raw data. Basically, we have over 2 years of data, and thanks to Thanos, we don't have raw data. We have downsampled data to after 1 year, we have 1 hour of data downsampled. Can be used for multiple tenants. Obviously, that's why Grafana developed Mimir. Grafana loves driven development. Yeah, it's Grafana Mimir, so it makes sense. But it's usually faster for queries, and not usually almost all time. If you have properly scaled Mimir, it's faster. Its query language processor is faster than Thanos one, even though Thanos made really some progress and it's faster than before, but still not so good. And different path getting data from Prometheus. Yeah, remote write versus Thanos sidecar. Okay, let's start with optimizing Thanos or deploying Prometheus, deploying Mimir. Let's start with optimizing. Optimizing consists of identifying the slowest part. We know that when we are querying the data, we are processing data queries through Query and Store Gateway. Query can be easily scaled. It scales pretty fast, mostly died because of out of memory, and not an issue. You can scale it easily. Store Gateway, on the other hand, it's not that easy. Can be monstrous when runs really having all data, and for us it starts for over 2 hours. One pod started over 2 hours, and we have like 2 replicas of the Store Gateway, so it was like 240 minutes. Yes, can be split. This is the way, but scaling is difficult. You'll have to use sharding. At this moment we have accessible 180 days of data, and we have 2 days of per replica, so we have 90 pods of store gateways. Only store gateways. Now it's pretty fast. You can get all of the data, and it's faster than it was before, so it's cool. But before sharding, we were able to get mostly 14 days of data, and then 9 days of data was from Prometheus, and 7 days for expensive queries if Prometheus wasn't accessible. By expensive queries, I mean like histogram quantil, which is pretty expensive query. Unfortunately, we use Bitnami Helm chart, so it does have no automatic sharding. But if you are running multiple tenants, you can use hash sharding, and that's good for them, good for multiple tenant setups. But that's unfortunately not us. Deploying Mimir, that's easy. Migration to Mimir, that's the interesting part. Mimir basically has 2 setups: Mimir distributed, Mimir binary. You can run Mimir in single binary, and yeah, that's it. Pretty easy, but not scalable. But for like home setup, it's pretty cool. You would like to run Mimir distributed, which actually happened. What happened like a month ago? I deployed Mimir distributed, and I almost crashed the autoscaler that Google has for nodes, because I scaled from like 14 nodes to 30 just because I deployed Grafana Mimir. Helm chart Mimir distributed. It's not from Bitnami. I mean, like, Bitnami does good job maintaining a lot of Helm charts, but they are not the best sometimes. And in case of Grafana Mimir, you can use Grafana Cloud, which will simplifies your workflow very much. But yeah, you are basically vendor locking and staying in the Grafana Cloud. So if you want to have data in-house, you can, because they are running in the cloud. Migration can be easy. It isn't. I learned the hard way. First things first, metadata. Metadata have a different format and Thanos. So basically Thanos stores external cluster information labels into metadata, not in the metrics itself, so it has to be converted. Thanos deduplication doesn't work because Thanos deduplicates data from the both, if you are running more than one Prometheus instances, then deduplicates data on the fly and no downsampling. Mimir can technically return the data if they are downsampled, but no, it's not recommended way. Yeah, so basically, if you want to migrate, you have to remove every downsample data. That's it, unfortunately. Apart of that, format of the Thanos and Mimir data are the same, and because Cortex have same data format as Cortex, so Mimir inherits that, and it's pretty easy to just copy from one S3 object storage to second. Remove duplicated data. Yeah, I said the duplicate. Thanos does that on the fly. Then you have to run script that injects external labels into the metrics itself, and that's basically it. Easy, right? You will have every downsampled data if you want to migrate to Mimir. So that's one big reason why no to migration. For us, it's 90 days, but if you want to have more data, that's are interesting for business, and it's basically no-go. If you don't care, then why not? You can migrate, it will be faster for you. You can technically run Thanos and Mimir at the same time, thanks to having different way how to get the data. It's not that hard, but you have two ways how to do that. You can run both of them and have Thanos only for the all data, have some kind of proxy that I didn't found if it even exists, that will recognize that you are querying all the data that are on Thanos and all the newer data that are on Mimir. And it will just do some kind of shenanigans to get the data to you. Or you can run both of them on the same time, run them all long enough, then just scrape the Thanos and you'll just have only the Mimir. Yeah. And thanks. I just forgot to skip the slide. Yeah, Thanos sidecar, Mimir remote, right? Okay, I forgot. Sorry. That was another question for you. Yeah, basically what Thanos and Mimir have in common, I said, but they basically have same thing, a different approach. And that's something that has to be taken care of. Okay, that was it. Now it's time for question and answers. If you have any questions, then please ask me.
Okay, so maybe I have a question. What is the reason to have two use of metrics data?
Don't ask me. Ask my like business decision makers. I don't think that we should care of this data because they are not critical. But yeah, if you have like business critical data, because you can scrape obviously the like business metrics with like what costs of the cluster or something like that. Yeah, that's basically it. But you don't have to have like 2 years of CPU usage of like one pod that is not running even anymore.
That was the reason of the question, because I can understand, like I can imagine that you can have some warranty towards your customers that you should provide some sort of SLA.
Yeah, that's yeah, that could be. Not for us. We are in industry, so it doesn't mean anything to us. But yeah, no problem. What will be new in Prometheus 3.0? a lot of things. Basically finalized remote write 2.0, same version of TSDB. That's not the change that will happen. But the reason why 3.0 exists is because developers can break things. Because 2.0 was very stable. Prometheus is very stable in versions that it's running at this moment, but developers and maintainers wanted to break things. Don't ask me what things, because there is a lot of changes. Even the beta version is a pretty big change. But mostly the remote write 2.0. And what is remote write 2.0, you ask? It's mostly in implementation of native histograms, because if you now implement histograms and they are not native, you have to create the buckets and manually. It's actually faster if you really know what the buckets are, but if you don't, then you can use native histograms. It has raw data, and it just generates the buckets on the fly. And yeah, that's it, basically. Are you using multi-tenancy in Mimir? Did you run any issues? No, we are not running multi-tenancy in Mimir. Basically, we are not running at this moment in the production because of the reason I mentioned. We are running in stage, let's say. But yeah, even though if we run in production, we will not run multi-tenancy. It's not necessary for us.
Yeah, I didn't catch it, but I just wanted to ask.
Sorry, maybe I didn't catch it, but what was actually the reason you migrated in the first place?
The speed of querying. Yeah, basically because of the store gateway is too slow and too slow to scale. We were looking for different approach to this issue, and because sharding is not that effective in Thanos, it's basically better to migrate somewhere else. Yeah. And you don't have much alternatives to Mimir, because you have Thanos, you have Mimir, you have kind of vector metrics, but we wanted to use object storage. You can use M3, which is not scalable at all. But yeah, it's fast if you want to run it. And yeah, Cortex is mostly dead project because a lot of maintainers just migrated to Grafana Mimir. And yeah, that's it. You don't have much more chances to go anywhere else.
Okay, well, thank you very much for the presentation.
Thank you.